and I would like to describe you what Caramba is offering for automotive OEMs as well as Tier 1 suppliers. A few words about the company. Caramba started in 2016. We already have agreements to protect over 12 million devices. By Q1 of next year, we expect to double this number. We have completed more than 70 projects, and we have 42 patents to protect our IP. Caramba started by protecting automotive car types and ECUs. We expanded our offering to protect other devices such as access points, as well as the enterprise edge and energy devices. These are some of our customers. You see here to the left, companies from the energy domain, Samsung, as well as SolarEdge and AP Systems, coming from the renewable energy, automotive OEMs and Tier 1s. We have many more that we cannot disclose without an NDA, as well as in the energy, as well as with the enterprise space, protecting storage devices, access points, and printers. In general, manufacturers started to treat product security as must-have, either in order to protect the brand if there are attacks involving their devices, then the brand is affected. We have customer requirements, and above all, you also have regulations. Clearly, as the one we have with the automotive industry, with the UN ECE WP29. If you don't comply with that regulation, you cannot sell new car types in the EU from July 2022 onward. In July 2024, every new car sold in the EU must be certified according to the WP29 product security regulation. And there are many other markets adopting that, going from Japan to China, where there is a draft of such regulation very similar to WP29 and others. However, when you want to start protecting your devices, to secure your devices according to the standard or in order to meet customer demands, then you face two major obstacles. The first obstacle is that R&D is not so familiar with what it takes to protect the device and to meet those regulations. R&D is much more concerned about new features, about delivering them on time with high quality. And there is a conflict between implementing product security as part of the device development and the firmware development lifecycle to delivering new features. And in many aspects, new features take priority, meaning that you have a built-in conflict between enhancing the product security to the R&D goals and agenda. The second challenge is that even if you do succeed and you have ways to protect the device, then the device by itself, IoT devices as well as automotive ECUs are limited. They're limited by CPU power, RAM size. They run, in many cases, RTOS, real-time operating systems, and they also use quite significant portion of legacy software. You don't want to change them. You don't want to change the device architecture or to change the legacy architecture. As such, changes cost quite significant amounts of money, and you would like to avoid such incremental or significant cost item. And this brings to Caramba. Caramba's unique value proposition is that it has a one-stop shop. We have products and services that enable manufacturers, meaning OEMs and Tier 1 suppliers, to protect their devices to meet the regulation throughout the life cycle of the device. Secondly, an important design guideline of our products and services is to make them as seamless as possible to R&D, meaning that when we deal with embedding security controls into the device in order to meet the regulation or to meet customer needs, then our point of interaction is the software build team, not the developers. We do not require any changes from the engineering teams, or QA, or even suppliers. Also, our ability to support quite a variety and a wide variety of ECU architectures enable us to add cybersecurity to protect the devices without requiring to change the hardware or the operating system or legacy architecture of the ECU and the vehicle type. And lastly, the team is extremely experienced. We have hundreds of years of cybersecurity products delivery as well as service delivery. If we look at the known V shape for delivering ECUs and car type, then you need to implement cybersecurity throughout the V-shaped diagram, winning is part of the software development lifecycle of the ECU and the vehicle type. In the left part, when dealing with requirements, designing and specifications, you need to provide an analysis of the design documentations. You need to analyze and identify security exposures and security risks. And once you identify them, you need to provide remediation in order to address those risks already in the design phase. When you get to the implementation, you need to first analyze the supply chain risks, all the third-party modules that you have, where are those security issues that may affect your end product, as well, and to embed security controls into the device firmware. And lastly, when talking about the testing and acceptance test, you also need to validate, continuously validate your supply chain issues. Those issues that were identified as part of the implementation phase, were they fixed by your suppliers? You need to do penetration tests for the ECU level as well as for the entire car type. And obviously, once identifying issues, either with suppliers or with your own systems, then you need to remediate them before going to production. All those phases are required as part of the WP29 regulation. You need to do the analysis in design phase, called TARA, Threat Analysis Risk Assessment. You need to do the checking your suppliers and embed security into the ECU's firmware. You need to do acceptance tests, validation tests, penetration tests, and obviously remediate issues that are identified. Karamba's products and services cover those three phases. We have threat analysis risk assessment service that enables you to analyze the specifications and identify issues within them. We're able to train, we offer training in order to meet the WP29 requirements. We have software, one of them is vCode to analyze supply chain risks and identify them, as well as XGuard, which is an embedded agent that is integrated seamlessly into the ECU as part of the implementation. In addition, vCode is used for the validation test, and we also have penetration testing services. So long story short, Karamba's products and services offer the entire V-shape, as well as enabling OEMs and Tier 1s to meet those requirements as defined by the WP29 standard. Now let's go deeper into each of the products and services. And the idea is that in order, when you have them, you cover the entire requirements. And now let's see what they actually offer. So in the secure design, we have starting with a training series. The training is for developers. We show them how hackers think. What are the vulnerabilities they're looking for in the code? so developers would be aware of what not to do in order to address those issues as part of their development best practices. Secondly, we also define and explain the standards that OEMs and Tier 1s must meet, the WP29, as well as the ISO 21434. And we conclude that series of training by making sure that developers are now hackers for a day. We give them an exercise, we enable them to hack codes and vulnerabilities based on what they learned in the previous sessions. And lastly, we also have a session for executive teams and product management teams, so they know what is required from them as part of the WP29 and ISO 21434 regulations. And then after the training, we also have the TARA service. TARA stands for Threat Analysis and Risk Assessment. You give us the product specifications and we analyze them in order to identify cybersecurity risks and attack surfaces within them as part of the design. We show here a list of projects that we have delivered successfully for OEMs as well as for Tier 1s. The output of that TARA is a report. The report shows the various issues in each of the modules. It analyzes those issues by the probability, what is the likelihood to exploit those issues and vulnerabilities from low risk to high risk, from low likelihood to high likelihood, as well as the levels of risks, meaning that issues that once exploited create a significant risk for the ongoing operation and business continuity to a low risk. But then not only we analyze each of the modules and identify those risks, including their likelihood to occur, we also provide a remediation document. The document describes the way to mitigate the risks, to mitigate the issues that were identified as part of the TARA exercise. We explain in that document what needs to be done in order to remove or to reduce the likelihood to low and to reduce the risk to very low. But then after the services, you also need to have the products. The first product is called vCode, and it enables you to identify and manage supply chain security risks, including open source. So vCode enables you to gain visibility into security issues in your binaries. It analyzes the binaries. You can, in order to identify problems that were implemented as part of your SDLC, in order to address them, whether if your own team created those issues or your suppliers. The idea with vCode is that you do not need to provide sources. You simply drag and drop the binaries, either to our own cloud or on-prem. You upload it into a Docker, and then the binaries are being scanned, they're being broken down to each of their components. Each component is scanned in order to create a report. And the report, which is obviously automatically generated, identifies those cybersecurity issues within that binary by module and by supplier. It starts with indicating CVEs, vulnerabilities in your open source modules by severity and so on. Secondly, it also identifies what we call risky tools, like a debugger. You don't need to have a debugger in a production firmware. It simply makes the life of the hacker much easier and simpler. It identifies credentials, outdated credentials that needs to be refreshed and changed. as well as weak passwords or no password, and so on and so forth. So the idea is that vCode enables you to get that report and visibility into cybersecurity issues by provider, by supplier, by open source module, and so on and so forth. So you can close it, you can mitigate and address those problems before the firmware gets to QA or before it goes to production. Nevertheless, we have learned that although vCode does whatever it does automatically, still our customers may not have the right manpower or sufficient manpower or knowledge in order to run vCode and to mitigate what it shows as a security factor and a risk factor. So in addition to vCode, we have a complete operational framework, meaning that we doing the work for you. For an additional fee, our team will operate vCode on your behalf. We will do the onboarding, we'll do periodical scans of the firmware, create the report and analyze them, as well as closing the loop, presenting the findings to your teams or to your suppliers with recommendations what needs to be done in order to mitigate those issues. So vCode analyzes the binary firmwares, the firmware binaries automatically, identifies, provide visibility and like an X-ray report of issues discovered in those binaries. And in addition to that, you can also use our team to operate vCode, as well as to advise in prioritization and in mitigation of those issues identified automatically by vCode. Nevertheless, according to the regulation and for best practices, you also need to embed security controls as part of your firmware. And for that, you have XGuard. XGuard is our software. It is seamless to R&D. You don't need to change anything in order to protect the device and to embed security controls into the device. With XGuard Suite, you don't need to change R&D or supply chain processes. It is agnostic to the hardware and operating system, and performance is negligible. How does it work? So first of all, XGuard also scans the binaries in order to implement security features as part of the ECU firmware. It is part of your toolchain build environment, meaning that the integration is on-prem as part of your own toolchain. Every binary going through the toolchain, meaning the linker, is scanned and protected automatically. And again, no need to do anything with sources, no need to change your processes. The build environment automatically protects your ECU firmware. What level of protections are offered? First of all, XGuard offers 3 layers of deterministic protection against cyber attacks. When talking about file-based operating systems like Linux, then we create a whitelist. The whitelist it enables to identify automatically all legitimate runnables, all legitimate objects that are allowed to run as part of the firmware. Within the build environment, XGuard creates unique values for each of the runnables. And in runtime, whenever a binary is loaded to memory, it's first being checked for its legitimacy. We compare the keys, recalculate the value again, and compare to the value that was generated automatically by XGuard, and compares the keys. If the keys are identical, it means that the binary that now is about to run in memory is legitimate and we allow it to run. If the keys are not identical, that means it's actually malware. So XGuard, by analyzing the files in the build, creating keys for each of the files, comparing those keys in runtime, enables to detect and to prevent malware from running. In other words, Xcode would prevent the attacks that happened on the Jeep Cherokee or the Audi as part of the infotainment hack that was on the Audi. All of them were done by dropping malware to the flash memory, running that malware to memory to the actual within the actual ROM. All that would be detected and prevented by Xcode automatically. Secondly, the second layer of protection is CFI, control flow integrity. What happens is that as part of the build, our Xcode software scans the binaries, create automatically a graph of function call and function return. Every possible call and return is mapped and instrumented. And then in runtime, whenever there is a function call and function return, it's being validated with negligible performance of less than 5% overhead CPU and RAM. If there is a deviation from the graph, it is a clear indication of buffer overflow exploit or other in-memory attacks. And we do not so for instance, this foo11 here, if instead of going to foo1 or to foo31 as it was supposed to, it's going to a different address in memory, that's a clear hijacking attempt or buffer overflow attack exploitation of the program. Our software detects it and prevents it. Such protection is plausible for every operating system, whether if it's POSIX-based, like Linux and Android, or whether it is RTOS, like QNX, or Wind River, or AutoSAR. Such protection mechanism is applied automatically in order to detect and prevent against such in-memory attacks. And again, with negligible performance overhead. And lastly, we also protect static files like data files and configuration files from being altered and changed. They must not change, they are not supposed to change. If there is a change to them, it's a hacker, and we protect against such changes. Those three mechanisms are added automatically to the binary firmware. They are as part of the build, and they enable you first to benefit from much stronger protection versus those that were exploited by attacks on Tesla or on BMW, both done by the Chinese hackers, Tencent, as well as other attacks that are quite common and severe in terms of in-memory attacks or in terms of a dropper attack. All that enables you to meet the regulation without changing R&D, without changing the supply chain processes, or even without changing QA processes. Nevertheless, we also have the agent that was embedded automatically into the ECU binaries, also enables you to monitor the actual anomalies in runtime. It detects and profiles a typical and normal behavior of the ECU by analyzing access to files and to applications, file system behavior, attempts to password hacking, and so on and so forth. And once there is a deviation from normality, it is being reported to the cloud. What is quite important is that today, as part of the WP29 regulation, you are supposed to start what's called a VSOC, Vehicle Security Operations Center. Once there is an anomaly detected, it should be reported to the VSOC. Problem is that each such event reported to the vehicle SOC costs you money. It consumes bandwidth. Secondly, it also costs you storage in the backend cloud. It requires, and given that the fleet size is usually quite significant, vehicles can be sold with fleets of hundreds of thousands to millions. then you face quite a significant cost problem of so many cars reported to the cloud. As part of our XGuard agent embedded for monitoring, we also do local analysis on the ECU, reducing and sending the data that only matters. About 1/10 of the data that is collected is submitted to the cloud. This is done in order to enable efficient management of the fleet, looking only at alerts that matter and save you costs, both in bandwidth and within the backend. All that is done automatically by the XGuard agent that is incorporated as part of the ECU firmware. So to summarize, Karamba offers you a one-stop shop to meet the automotive security requirements and regulations. You could benefit from Karamba and delegate to Karamba the cybersecurity tasks in order to meet the various stages required to certify to meet the WP29 regulation and standard. You can use parts of the services, not all of them, or the entire portfolio. It starts with training that is mandated by the standard, continues with threat analysis, risk assessment on your design documents, as well as a remediation plan, what needs to be done to reduce the risk profile. Then our software enables you to automatically validate your supply chain security issues and compliance with the standard. Our XGuard suite is embedded seamlessly to R&D as part of the ECU. XGuard is ASIL B and ASIL D certified, so you can incorporate it as part of the QM devices, as well as the ASIL devices that are safety sensitive. You can use XGuard for all that variety of ECUs, and again, seamlessly to R&D, providing levels of protection as well as compliance with the standard. All that is done automatically. And lastly, you can also use our services to do penetration testings and remediation of issues that are identified as part of the pen tests. All in all, with Karamba, award-winning products and services, Karamba is considered as a leader in the area of IoT and automotive security. We were honored by Forbes, named one of the top 20 IoT startups to watch in 2020. Gartner called us a cool vendor for IoT security. We were selected as the best cybersecurity product 3 times in a row by TU Automotive Detroit, as well as the best of show at Interop Tokyo 2021. Thank you very much. We will be happy to meet and answer any question that you have.